In this video, we will investigate equivalent fractions. Equivalent fractions are fractions that have the same value, even though they might look different, because they have a different denominator, that is, a different number on the bottom. And to start with, I'm going to draw three nearly perfect horizontal bars, and each of these is going to represent one whole. Well, not quite perfect. They're kind of limited by my ability to draw a straight line. There's the second hole, and here's the third hole. Well, to investigate equivalent fractions, we are going to use the fraction 2/3. So I'm going to write that down here at the bottom. 2/3. So if this is one whole, if I want to get 2/3, I first have to divide the bar into three equal parts. And let's pretend they're equal even though I haven't drawn them perfectly. So I have 1, 2, 3 equal parts. I'm going to do that to each of my bars. And we are interested in the fraction 2/3. So one whole is 1, 2, 3/3. I am interested in two of those. So I'm going to outline in blue 2/3. And I'll do that for each of my bars here. Okay, so each of these blue rectangles represents 2/3. Well, let's move on to talk about equivalent fractions. I'm going to take this second bar and I'm going to divide it perfectly in half, the horizontal line. Now my whole has been divided not into three parts, but into 1, 2, 3, 4, 5, 6 parts. So now I'm no longer dealing with thirds, but with sixths. So I'll write that over here. And how many sixths is my 2/3? Well, it's 1, 2, 3, 4 sixths. For the third bar, I'm going to divide that whole using two horizontal lines. One here. I'm doing this in such a way to divide it perfectly. So now, instead of having three equal parts of my whole, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 equal parts. The part I'm interested in, the 2/3 here, is made up of 1, 2, 3, 4, 5, 6 parts. So this is actually 6/9. So my poor drawing notwithstanding, each of these blue rectangles encompasses the same area. So 2/3 must be equal to 4/6, which must be equal to 6/9. Let's take a look. In going from 2/3 to 4/6, notice that the 2 on top here simply got multiplied by 2 to make 4. The 3 on bottom got multiplied by 2 also to make 6. And that makes sense. I started with 1, 2, 3 parts of my whole, drew a line straight down the center, dividing each of those parts into 2 parts. So 3 times 2 is 6. I was initially interested in these 2 parts up here, this part and this part. That same line that divided my whole divided each of those parts into 2, doubling the number. So 2 times 2 is 4. Well, what about going from 2/3 to 6/9? 2 times 3 is 6. 3 times 3 is 9. Let's take a look at this. I originally had my whole divided into 1, 2, 3 parts. By drawing those 2 horizontal lines, each of those was divided into 3 parts. So 3 times 3, 9. I now have 9ths. Originally, I was interested in these 2/3, but each of those thirds got divided into 3 parts. So 2 times 3 is 6. Makes sense. So now we have a way that we can make all kinds of equivalent fractions. I just have to multiply the top and bottom of the original fraction by the same number. Let's pick 4. 2 times 4 is 8. 3 times 4 is 12. So 8/12 is also equivalent to 2/3. Let's try 5. 2 times 5 is 10. 3 times 5 is 15. So 10/15 is also equivalent to 2/3. So on, so on, so on. I can pick any number, multiply the top by that number, multiply the bottom by that number, and I'll get an equivalent fraction. And again, this is an important skill for adding fractions with different denominators. That is, with different numbers down here on the bottom.